So it should start recording soon. So yeah, so if we take, I don't know, a command like this one, this does a bunch of stuff and then produces an output. If I load the Boomer library, I think I probably did. If I put as a last command boom, it will at each step print the output. So it inserts kind of a break in each one to show what's going on. So one thing I would suggest if you're going to do this is to make it a tibble, because data sets print really noisily. But if we do that, it just for each step in for each step in your command, it prints whatever's going on. So if there's an error, it will help you find where the error is. So it solves that problem, because what everyone's always done with Dipler before, when you've got all these pipes, is like if this breaks, I would say, okay, I'm just going to run this code. So I highlight the section I want to run and run it. And if that works, then I move a section down. If it doesn't work, I move a section up. This boom command will help you do that kind of automatically, because it does each step consecutively, and so you can see which step is breaking. The error, I do find the error terms with Dipplers are pretty clean, so it's not, you can often do without it, but it's a useful library if you're trying to debug like a Dippler set of pipe commands that were working last time you started R, and either because of a data update or because of something you did when you closed R last time, it's not working anymore. So yeah, onto ggplot itself. The idea with so ggplot stands for Grammar of Graphics, and if you go, I always so Grammar of Graphics is it's a grammar that I do find a little confusing. I don't find it, as I learn more, I'm more and more comfortable with it. I do find this is one of those libraries that more than any others, I find myself typing like ggplot, barplot, something to find a web tutorial. And I've linked to 3 good kind of blog posts on how to do these things in the lecture. But today we're going to go over kind of the same kind of basic plotting we did before. If you want some expanded examples, the ggplot library, the main page for it's pretty good, mostly because of these 2 cheat sheets. They're the kind of things that if I'm ever back in my office, I will probably print these 2 off and stick them up beside my desk, because they have kind of all of the basic commands. They're the kind of things that I find myself constantly Googling. So I'll probably add them to my desk, the same way I have a table by my desk to tell me what sensitivity and specificity are, because I can't keep those straight either. As well, if we go back to the R for Data Science book, chapters 3 and 28 specifically talk about ggplot, but ggplot is used throughout the R for Data Science textbook. So the idea of ggplot is that you say, I'm going to plot a data set, and then you start adding plotting components to it. So the general idea here is I'm going to do a plot on a data set called dat.reduce. Oh, I want to point that out. I have a command here that is just taking a subsample of 200 people from the Framingham data. I just wanted a slightly smaller data set for some of my plots, so they were a little more readable. You can do a scatter plot on the full data set. Just for teaching purposes, 4,400 data points just looks like a blob too often. So I will use the full data set when I'm doing histograms and things, but I wanted my scatter plot to be able to see the dots. So what this says is I'm going to do a ggplot on the data set, and I'm going to add points. And what you do is you add points with, and this is where I find the terminology a little bit confusing, you add aesthetics. And it's a weird way to say it, but the idea is I'm plotting this data set, and within that data set, I'm going to add an aesthetic that has systolic blood pressure on the x-axis and diastolic on the y-axis. And then I'm going to take those and do a scatter plot, which is done using geom._point. So when you combine these, it produces this figure. And the general idea is ggplot the data, and then you have a function that lists aesthetics that you're going to add to the plot. Now, one of the nice things you'll find, sorry, this has a kind of same assembly line like construction that Dippler does, only the difference is instead of pipes, we're using pluses. So here we string commands together with pluses instead of pipes. I think if you try and run a ggplot command with pipes, I think it actually gives you a, yeah, error mapping must be created by AES. Did you use pipe instead of a plus? You'll find if you're working a lot with the two libraries together, you will find yourself doing that a lot. So they've come up with a way to detect and correct that, hint at you that you probably piped it the wrong way. So the other thing to note is that even though the aesthetic occurs in, like, it's needed in the plotting function, if I specify it up here, if I specify it in the main function, it will pass down to all the other ones. And I kind of find that a little more intuitive. So I'm going to create a plotting space that has blood pressure on the x-axis, diastolic on the y-axis, and then I'm going to do it as a scatter plot. So I'm going to add a scatter plot to that. Note that the other nice thing is that ggplot, because it's part of the tidyverse, it always starts with the first argument is always a data set, so it works well with pipes. So you can see here, rather than doing ggplot on the data set with the aesthetic, I can pipe the data set into the function. It'll make it the first argument, and then I can just list my aesthetics. The advantage of doing it, there's no real advantage in this exact case of doing this rather than this. The only advantage would be that if I want to do some data manipulation, like if I want to remove missing values or remove high values or something, I already have it. This is combining my data prep step with my data plotting step. So that's the only thing I've changed here. The other thing I've done is I've added a second aesthetic. So you're not restricted to a single aesthetic command. You can add them as you go. So in this case, I've taken this plot. Most of what I just did was rearranging things, but I also started coloring them by sex. So I added an aesthetic to color them by sex, and now I get the male and female dots separately. When you add a component, but don't try and overwrite them. So like, I can't change what X is here. If you specify X twice, you get some inconsistent results that you'd only ever need for very specific cases. So you can see it. If we go way back to the beginning. So I'll make this a little bit bigger. I forgot I was supposed to do that. 16. Which was this one. So there's the one I just did. If I try adding X equals to call, you can see that it has changed. The x-axis values are cholesterol values, but because my function thinks that X is systolic blood pressure, it has still labeled this as systolic blood pressure, but the values it plotted, because it overwrote them here, are cholesterol. So the only place you would ever do that is if you were doing, man, it's hard to come up with a reason to do that. If you were doing, like, sometimes you'll see multiple y-axis plots where like the left y-axis is one value, the right y-axis is another. I could do something like y equals diabp plus geome point AES color x. So I could do a plot with two separate. So these are the. God, I have to think about what this means. These would be the blood pressure values. These would be the cholesterol values. So if you have one of those cases where you have a y-axis left or right side, and those are rarely good plotting functions. I know that Yukiko's done a lot of research on effective presentation of graphics. I would guess that though that literature rarely recommends having multi-axis plots, but I don't want to say it's never appropriate because I'm sure I've seen once or twice in my life where it is appropriate. I'll just say that it's rarely appropriate. So try not to re-specify. Don't specify an X or a Y multiple times in a graphic, because the problem is that what you didn't see in any of those was an error, right? There were no, it didn't warn me that, hey, you specified Y twice. Did you mean to do that? So the nice thing about ggplot is how it's built in parts. So we had this command. Note in this one as well, I had specified color in the point, but as before, I'm going to move it up to my main plot, my main command, because I want that aesthetic to be true for all my subfunctions. So now I'm adding smooth curves. So there's a command called geom_smooth that will add smooth curves to the figure. So if you the way I usually write this is I would start with this gives me my scatter plot. I want to see what the best fit is, so I just add a geom smooth, and that gives me the figure. And then if I don't want the confidence intervals because they're crowding the figure too much, I can just take them off by changing the value. Oh, the other thing I did I do it here? Yeah. So the other thing that happened in this command was I moved color up, but I also added a group variable. And the difference between color and group is subtle, but it is important. So when you add a group to an aesthetic, like when I add group here, it tells me that I'm going to split my data by sex. So my data is now, you can think of it as there's a set of values for men and a set of values for women, but it doesn't intuitively change the plot. So if I were to do, let's take the original one, this one, like the black and white one, and I add a group equals sex, the data sets are separated, but I didn't add anything to visually differentiate the two. So like it plotted the male values and it plotted the female values, but it plotted them both in black. So you can't see a difference. So group is a group you can think of as a structural argument. It tells the functions that I want you to do things separately for each of these, each level of this variable. Color does the opposite. So color tells you when I was doing this, I was telling it color the dots with this variable, but all it's doing is coloring them. It's not adding that as structure to the data. So group adds structure but no visual modification. Color adds visual modification but no structure. So you'll find yourself typing color equals variable, group equals variable a lot, because typically we want to. Oh, I can actually show you. If we take this one, so this is the one with the. If I have color but not, oh, I didn't think that would work. I thought I had to have group. Must be when it was down in the smooth. Um, uh, Maybe I'm a liar. If I want separate lines, if I wanted a single line, I think I would have to do it like. Oh, that's something else you're going to find yourself doing a ton, is forgetting to wrap things in AES. So color isn't an argument that geom point takes. Color is a component of the aesthetic, and geom point takes an aesthetic. So you have to remember to, there we go, that'll work. Yeah, so here's an example of getting, that's one line of best fit for where what I really want is two lines of best fit. So the final thing I did was there's a function called labs, and I just changed the labels of all my values. So labs takes as arguments any components you pass to your aesthetic. So because I have an X value, a Y value, a color variable, and a group variable, I can set the titles of X, Y, color, and group. So in this example, you can see the original one had sex here as the label for my colors. I didn't want that word sex there. It's intuitive what male and female means. So I set the title for the color aesthetic to be blank rather than being the word sex. And I just changed X, Y. Beyond the aesthetic components, it also takes title, subtitle, and caption. And then there are also specific functions. So rather than doing lab X equals something, you just do X lab and then the name in quotes, but it works either way. So on to the kind of three plots I want to go over. Obviously, line plots I've talked a fair bit about already. Desk is a little low. The only other variables for geom point that you might be interested in are the shape and size arguments. Shape is the equivalent of the PCH argument. It controls what shape is being plotted, and size is the equivalent of the CEX argument. So size is just the size of the dot. So you can't just pass them as integers. So size is 3, just makes them 3 times as big. Shape is 17. I think we talked before that there were like 28 different shapes, and if you run the examples command on points, is that the right one? Examples points. Oh, every time. There we go. There they are. So these are the like 25 default shape numbers. So we chose 17 here. So it will take the same ones if you just want to change your keep going. There we go. So I'd made 17 just to make it triangles, but you can also more interestingly pass variables. So now what I've done here is the size of my dot is proportional to the BMI group they fall in, and my shape variable is different for males and females. So I have it both colored and shapes. I would suggest doing that as often as you can. It's more friendly to colorblind people, because this palette is pretty good for colorblind people, but it's not a super colorblind friendly palette. These are shades of red and green that I think tend to be differentiable for red-green color blindness, but it's not. These aren't the best shades you could pick. These aren't like colorblind optimal palettes, but they're better than nothing. And I think size doesn't need to be a category. We can make it a continuous variable as well.
Hey.
Hello. What happened?
Hey, Kika.
Sam disappeared.
Did Sam?
Okay, Sam disappeared. I thought it's me.
Yes.
I thought my computer was frozen.
I thought so too. Maybe we can wait.
Yeah.
I thought mine was frozen as well. I was like,
Yeah,
all right.
everybody thought it's ours.
Yeah.
I think it's probably Sam's.
Yeah.
Cool.
Okay.
Yeah. So Yukiko, what do you think about those graphs where they have two y-axis?
I think as Sam said, sometimes it works, but yeah, you have to be careful.
Yeah. What are your favorite graphs?
Dot chart.
Yeah. Okay. Yeah. I think I was gonna say that makes sense because it's like yeah. And then you can change the size of the dots for more information too, and the colors.
Yeah, probably. I have no. So what I learned is that the best graph is the least taxing to brain. So the simplest way. So for example, the same information can be drawn by bar chart and dot chart. The reason why dot chart is better than bar is that there's no information added for the area.
Oh yeah. Because
Yeah.
the
Yeah.
bar chart has like the thickness
Yeah.
of bars and stuff.
Yeah, and it's actually distracting to the brain because when we see fat bar, we try to infer some more information than it's intended.
Yeah.
Fat is more important or more is there and thin is not, kind of thing. So brain start to work that way. That's not what we intend
Oh,
to
okay.
convey as message. So then to remove that distraction, it's really, we can do just dot chart, like a dot and then line length. So that's what we want to show. So that's the basic idea.
Oh, okay, cool. Yeah,
Mm.
I think that makes sense.
Yeah, and it's established literature I think it's in psychology. And yeah, it's interesting to see that it never became very popular in health. So we don't see so many dot charts.
Yeah. Okay, interesting. Yeah, I haven't. I guess I've gone through the health literature a little bit.
Mm.
Yeah, I
Yeah.
don't know actually. I don't know what kind of charts I normally see in economics.
Econ is not that great, but I think everybody does like a descriptive one is the bar and histograms and then scatter plots and the common thing. But
Yeah.
hi Sam, you're muted.
We'll see how this goes. My internet just died. I doubt there was. My
Oh,
nanny heard a big bang and then the internet stopped working. I don't know. Anyway, I didn't have a chance to investigate it. So I'm running off my phone right now. We'll see if it has
oh
the
my
bandwidth
goodness.
to.
Are you okay? Like you
Yeah, I
don't
mean,
need to pay forever? Like all the salary goes to cell phone bill?
yeah, we'll see. We have a crazy amount of data, though I don't know if streaming video is the best long-term solution. We'll see. It's only for an hour. We should be okay. But
yeah, we all thought that, and it's each of us. I thought, and my computer died, and everybody thought that way.
where were we? Oh, right. So I was talking about the size argument, right? That you can. It doesn't need to be a categorical variable. If you pass size as a continuous variable, it will kind of like split it into reasonable breaks based on your data. So the yeah, so then the other thing is well, I had the guides argument here. I know I did that. So we can see that to add lines to your scatter plots, geom smooth is the one to add the lines. The default value is a low S curve, which is essentially like a rolling average. The Wikipedia article explains it pretty well. But the other methods are LM, and you can do GLM if you want to fit like an exponential curve. But if you set method equals LM, that adds the straight lines. And I've also taken the confidence intervals off. So I don't want the confidence intervals, I just want the lines, because the confidence intervals on a straight line I find can be a little distracting, especially when they're so close to each other like this. Oh, guides equals false. What I did was I wanted to take, so guides is the legend. That's what they call the legends here. So I wanted to remove the legend for size and just keep the one for sex. So I removed the one that described the BMI groups.
Excuse me, Sam.
Yeah.
Could you share your screen? Yeah.
Oh, is it not shared?
Oh no.
I've got the red box. That's weird.
Yeah. We see. Yeah, it's weird. And Yukiko is like half of my screen.
Yeah, I see Yukiko and Sam like two close-up faces.
Is it sharing now?
No.
No.
That's weird. So let me try canceling it and sharing again. It might be confused. Like I might have to close out of the meeting because I never actually left the meeting. I was just on hold for a while.
Oh.
Yeah.
So I might have got confused. Do you see it yet?
No.
No.
Okay, I'm gonna leave and come back.
Okay. Wow.
We have really small number of people today.
Yeah. 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 It must be. Is it close to the end of? It must be close to the end of the semester now.
Yes, I think students are busy.
Yeah. That makes sense.
Yes, I know for the first years, our core course is just finished, but
Yeah.
I don't know about the electives, but this is
Right.
our first few days off.
Right. That's right. How are you, Natalie?
Good, good. I have about another week before clinical epi starts, so
Yeah.
we're all enjoying our sort of week and a half off.
Right. That's good. Did everything go well this term?
This term was harder than last term, but I think we're
Yeah.
all glad to be finished it.
Yeah. 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 It's usually the case. The second term is you have to use your brain much more extensively.
What program are you in, Natalie?
Community health and epidemiology.
Oh, okay, cool. Yeah, feel like I should take a few of those courses related to that.
Yukiko, have you already chosen the students for next year?
Yes, we have.
How big is the class?
We made an offer to 17.
Oh, really?
Yeah, but inevitably we will receive their rejection.
Oh, yes.
Because many students are applying for different programs. So far, we have not heard anything, sorry, I can't come thing. So it will be our, and then we have 2 students deferred from last year.
Oh, okay.
Yeah, so somewhere between, I'm hoping like a 15 to 19.
Yeah. Yeah, that's so much larger than the class ahead of us, which was, I think, 9.
Yeah, so we made a deliberate decision to bump up a little bit.
Oh, that makes sense. Okay, yeah.
Yeah.
Interesting, yeah.
Yeah. Ah, it's now shared. Good.
Yeah.
Thank you, Sam.
I'm connected to my wireless, but my wired connection was still plugged into my computer, and halfway through our conversation, it just decided to start sending stuff to that. So it looks like it's better now. So yeah, moving on to box and violin plots. So the command for box plots is geom box plot. You'll start to notice a pattern here. A GEOM underscore, then the thing you want to do is often, and this is often a place where the autocompletes in R can be your friend, where like if I wanted to add this won't work, but if I do geom underscore, you can kind of see that it adds, there are a whole bunch of options, but if I do box, it'll give you the name of it. So the ggplot commands are fairly well named with geom underscore, then the thing you want to do. Now it isn't always going to be clear, I think we'll see later. Bar plot's called bar rather than bar plot, but it's pretty good. So box plots are pretty straightforward. Y is the variable, is the value you're going to be box plotting, right? Because on a box plot, the y-axis is the plotting space. If you want to stratify your box plots by something, which you tend to do, right? We rarely present a single box plot. Then just pass an aesthetic called X that is what you want to stratify by. The only other argument is this fill argument, and there's a slight difference between fill and color. So fill will fill your box plots. Color does the outlines, gives you a white filler. I kind of like these ones, but to each their own. And you could actually do both, but that would probably be I don't think it will work out well. I think you're going to end up with like red on red, and it's not going to be that readable. So that's what it looks like with fill. If we were to add color equals BMI group. Yeah, so this is the same color on top of one another. So these are red filler and red lines, which means you can't see anything. So I would avoid that. But we could do color equals MAG. I think that'll work. Just in case you wanted something really ugly. So yeah, the difference between fill and color is there. Great blog post. So I think for histograms, box plots, and bar plots, I've linked to R4HDS tutorials. I don't know who the statistical tools for high throughput data analysis are, but they have some great ggplot tutorials. I don't normally link them because if you Google ggplot histogram, I get this as one of my first couple results. And it just, as you can see, like it just gives you a bunch of examples. If there's something you want to do with a box plot or a bar plot aesthetically, they have the options for you. And they have similar ones for histograms and bar plots that I find helpful. I tend to prefer violin plots to box plots. If you've never seen a violin plot before, it's the same idea as a box plot, only instead of quantiles, it's I can't remember the name of the term that forms the edge. They're Gaussian something. They're the idea is that this is a smoothed histogram of the data, and when you mirror it, it creates what often looks like a violin shape. So a violin, geom violin is what creates those. It takes essentially the same arguments. So we see AES, fill groups. One thing I like to add to my violin plots is drawing the quantiles. So if you draw like the 25th, 50th, and 75th percentile on your violin plots, these these three lines represent what would be the box plot data. So if you did these as box plots, these three lines represent where the boxes would normally be. So it gives you that box plot data if you're more used to that. But you can if you look up the help file for violin, there are a couple other arguments you might use. Now moving on to bar plots and histograms, the big difference here is bar plots are for categorical data and they're essentially plots of a table, and histograms are distributional plots of a variable. So we can see that histograms only take a single X value. So this is the X value is what you're drawing the histogram of. The Y axis is going to be predefined as the count, so you don't set the Y axis. Famous last words. I'm pretty sure I get an error if I try and set the Y axis. Y equals X. Yeah. So this command only works with an X axis. You could also turn it sideways. If I want a sideways histogram, I can do it by setting the Y axis. So I can do a histogram with a Y axis. Just with histograms, you can only set one value. And the default here, as with R, is to do stacked histograms. So these are the pink values represent the males, the green represent the females, and they're stacked on top of one another. I find that doesn't tend to be what I like to do. If I'm doing stratified histograms, I want them beside one another. There are occasions you might do stacked histograms, and there's some interesting plots you can create with stacked histograms of values that always total 100%, but that's something you can play around with. If you change position to identity, that makes them overlap, but the problem with overlapping is that the colors don't naturally mix. So if I run it without this alpha value, you just don't see a lot of pink because the blue is overlapping. I'm not sure what the principle is for doing the males before the females. Maybe that's the order that they're done in the variable. Yeah, so I must do them in the order of the factor variable. If you what you can do is set the alpha channel. So the alpha channel controls transparency in any color, and it's so if we set alpha to 0.05, that makes each one 50% translucent, and then we can see the pink behind the green. This works for any color. So one thing you can do is, how can I demonstrate this? Just 6. Just 1 second. Library, color. Dot. I just want to put. I need a hex code, and I'm blanking on another way to do this. Set 1. So these are the 9 hex codes that are part of the first palette for the R Color Brewer library. So if I were to just do a histogram of sex, $signs call equals S11. Oh yeah, what am I thinking? Let's do BMI. So these are the BMI values. If I, instead of, so we look at S11, this is a hex color. And if I add 2 more digits to that, the last 2 digits are the transparency. So if I were to make X equal paste 0, S11, what's half of a hex digit? 80. So if I change that, I've taken my original color and added an 80 to the end, which I believe is about halfway up the 2-digit hex code. So now if I do the same histogram, but change that to X, I now get what is essentially a pale pink because that is a 50% translucent. So any hex color, this actually works almost anywhere so this works with web programming as well. If you're anywhere you can specify a hex code colors tend to be 6 hex digits because it represents the red, green, blue values of the color. That 4th value, if you add 2 more hex digits, then you set the translucency. So I can, if I were to change this to be all the way up to like EF, this is going to be, oh no, I went the wrong way. That is almost no translucency. If I were to go to like 0.5, that's almost completely translucent. If you really pinch your eyes, that isn't white. It is like 1% pink. So the alpha channel is really useful for overlapping colors, and you'll find it's a really useful thing you can use a lot in your plotting, particularly when you're working with hex colors. For bar plots, rather than geom histogram, we're using geom bar. This is one of those things that, like, the minor things that drive you nuts. Like, if this isn't geom hist, why is this geom bar? Like, if histogram gets a full word, bar plot should get a full word as well. Maybe they might have a policy that the word plot doesn't appear in any functions except for ggplot. I don't know, but it's such an odd decision for them to make. So works similarly, only we're now doing X has to be categorical, and again, no Y. And once again, that the problem we have is the default is stacking. So we're going to make the position equals dodge this time, and that makes them beside each other. We could also do position equals identity to make them overlapping. Overlapping bar plots I find incredibly confusing, and it's rare that they're the appropriate thing to do. Not surprisingly, we have another blog post here that shows what how to do this in a variety of different ways. So they kind of outline the other arguments you might use. So we're going to go to breakout groups. How many people do we end up with? 10. So we'll do 2 breakout groups. We're going to go back to what we did in week 3, but now try and do it with ggplot rather than with the base plotting function. So we're going to do a scatter plot of, in week 3 we did systolic versus diastolic, but I ruined that by doing it earlier in the class. So we're going to do a scatter plot of cholesterol versus BMI, a histogram of systolic blood pressure. In week 3 we did a box plot of systolic blood pressure stratified by sex. I would suggest doing a violin plot, but play with both. The functions work essentially the same. So look at both. And these last 2 are a little more challenging. So I want a scatter plot of systolic versus diastolic for people with normal BMI. And just a hint that you solve that. You solve that with a data manipulation, not a ggplot. So this is where you can practice that piping the data into ggplot so you can do data manipulation. And this last one I didn't teach you at all, but if you want to look up facet wrap or facet grid, they can explain to you how they work. That's useful for stratified plots. And it's one of the more useful things that ggplot can do is quickly creating kind of these paneled plots. So I'm going to send you guys to breakout groups, and we'll come back in about half an hour. Oh, I have to recreate the room just a second. All right, you should be going now. Now. All right, I'm going to take a 5-minute break to figure out why my internet broke and make sure my house didn't break. But I'll come join you. Yeah, no, the internet's just not working. There we go. Yeah, seems like you guys made good progress, and you can really kind of see with these ones. I find these are really good ones for practicing how to do these things in steps, and it's where you really get that practice of the real advantage of the grammar here, where what seems at first like it's unnecessarily complex. Bit like learning new math. I don't think Dan's not here, so his kids are older. New math seems ridiculous until you realize that that's how people think. So what's complicated at first is actually how people do math in their heads, and it's a benefit in the long run. So the first four were pretty good, but even this one's a good example. So for that third one, we were going to do a scatter plot of systolic versus diastolic, but filter on BMI. So this is the full scatter plot, and then all we want to do is we want to filter. And the advantage is that we have all those tools built into the Dippler library. So if we filter on BMI groups equals normal, then we can what did I do wrong? Be a data frame. Did I break that? Oh. Remember I said that you might accidentally use pipes instead of pluses? You can do it both ways. This error isn't as informative as the other one. The other one, when you have a pipe instead of a plus, it tells you specifically, do you have a pipe instead of a plus? The second one isn't as useful. So yeah, so there, if we want to filter it just based on the normal BMIs, but instead of filtering it, what we want to do is we want to stratify it by BMI group. And the reason we want to do that is that we could color it by BMI. But that's not that informative, right? Because it's just a big mess. So what I'm going to do is there are two libraries that are useful, two functions that are useful here. Facet wrap, wrap. And we're going to facet by BMI groups. So you can look up the facet wrap and facet grid functions because they are different. One of the important differences the scales are. So if I do scales equals fixed, that becomes the default value. That means all 5 plots have the same scale. If I do scales equals free, that makes each plot have its own scale. Yeah, each plot has its own scale. So each one's filling their space, though they obviously become less comparable in this example.
What's the default again?
Fixed, I believe, is.
Oh.
The other command you can try is facet grid. And what this does is this grids it based on variables. Now for this example, it doesn't look that different, only it's made it all one row. But if we want to compare it across the sexes, now we get the males and the females, and then the 4 category. So I'm going to add a shape difference. As I said before, whenever you color something, doesn't hurt to also shape it. So that just differentiates my top from my bottom. And now the final thing I want to do is I don't really like this 5th column over here. I don't like the missing that because there aren't enough of them. They're not that interesting. They're crowding my plot. And this is where I use combining the two. So I'm going to go back to my data commands and drop the subject with missing. It's causing me trouble. BMI groups. So once I drop them, when it builds my facet grids, it then drops that last column of plots because they weren't, they just weren't what we were looking for. So That's even more useful if we do the facet wrap, which is what I'd asked you to do. Yeah, and those are the fixed scales. So, call them. Anyway, it doesn't really matter. So yeah, so that's ggplot. There's obviously a lot more to do with it, and next week we're going to talk about how to take what we learned the last 2 weeks with data manipulation and plotting, and use it to improve your reporting. How you can use the data manipulation to generate figures like this, and I'll pull in some examples from some of my other projects on how I've used these to create, especially with the facets, some really useful graphics. So I'll hang out for a couple minutes, although I have to call Bell to figure out what's wrong with my internet. Well, I know what's wrong with my internet. I went outside and the wire fell down, so I need to figure out what happened. What I have to do to get that fixed. But yeah, I'll hang out for a couple minutes if anyone has any questions.
Yeah, thanks, Sam.
Thank you.
Thank you, Sam.
Thank you, Sam.
Thanks. See you next week.
Bye, everybody.
Thank you, Sam.